Okay, so today we're going to talk about section 7.2, which is scientific notation and powers of 10. And so our objective today is to multiply by powers of 10 and understand what powers of 10 really are. And then our second objective is to convert to and from what we call scientific notation. And we're going to learn about what scientific notation is. First of all, in order to do this, we need to expand on what we know about exponents and what we learned last time around for section 7.1. By now we should know what these really are and what these really mean. That you know that these things here, this means 10 times 10 times 10, and if you evaluate this, you get this to equal 1,000. And we can keep going on and doing this, and we can say that this is 10 times 10, which we know is 100. 10 to the first power is just 10, because remember, anything to the first power is always itself. The next rule that we have is anything to the zero power. What do we know that is? Well, we know that this is always equal to 1. And then if we do this one, remember, okay, well, negative exponent, reciprocal, so 1 over 10 to the second power, which is 1 over 10 times 10, which is equal to 1 over 100, okay? And then this one here, same thing, 1 over 10 to the third power, because that negative exponent makes us do the reciprocal. 1 over 10 times 10 times 10, which is 1 over 1,000. So we can look at these and see about these, and let's take a look at those, and you can pause the video if you need to, but take a look at these and see what's really happening here as we change the number on our exponent. So, going on to this next slide, is there anything that you noticed? So if we set this up into a table and really investigate, okay, instead of using fractions, let's use a decimal. So as we move from one thing to the other, okay, as you can see up here on the top, each time we move to the right here, we're dividing. And notice your exponent. Let me zoom in here just a little bit. Notice your exponent here. What's happening to our exponent? Well, it's decreasing. It's going from 3 to 2 to 1 to 0 to -1, -2, and -3. And if we look at the value of what's really going on here, if we see that here it's going from 1,000 to 100 to 10 to 1 to 1/10, 1/100th, and 1,000th. And we can actually go back the other way too as well, and as we're increasing, we're going from 1,000ths to a hundredths to a tenths to a 1, tens, 100s, and 1,000s. So what we're really doing here is that every time we multiply by 100 down here on the bottom, every time we multiply by 100, we're in a way moving a decimal point to the right. So we're going from here, and it's moving to the right, moving over, moving over, moving over, because remember, these each have that imaginary decimal point here, here, and here. And in similar fashion, if we look up here, when we divide by 10, we're going backwards, we're going to the right. Look at what's happening here, is we're moving the decimal point in the opposite direction. We're moving it now to the left. So we're going to the left, so that now we have, the 1,000, 100, 10, 1, and so on and so on and so on. So as we divide, we're kind of decreasing our number, or as we go here, look at our pattern and our power. As that number decreases, our number is going to decrease. But does it ever go to something past 0? Well, no, because this decimal right here is just going to keep getting smaller and smaller and smaller, so we can kind of hypothetically say that 10 to the 4th is going to be 1 over, probably add 1 extra 0, wouldn't you think? And so we would get 0.0001. And then so we can look at this and we can say, well, yeah, things are changing here a little bit, and whether our power is different depends on what our number is. So let's look at this a little bit more in depth as we move on to our next slide. Okay, so what do we do with this now? So what we can do is we can kind of state that in this kind of realm, everything kind of revolves around the number 1. So if we always think about the number 1, and we're And you might say to yourself, okay, well, why the number 1? Well, if we say, starting with number 1, we say 10 to the power of n, where n is any integer. So this can be any number that we think of. And remember, integers are positive and negative whole numbers that include 0. Now, just take a quick look at this real quick, and we can say, well, we're talking about positive, and then we're talking about negative numbers, right? Well, if we're talking about positive and negative numbers, what about 0? Well, if we say, we're going to come up here, and I'm going to point an arrow to 1, 10 to the power of 0, well, what does that equal? Well, we know that that equals 1. So if we think of 0 as being the middle of a number line, so if we draw our imaginary number line here, we have 0, negative 1, 1, 2, negative 2, and so on and so on and so on. So 0 is kind of our middle, so everything else revolves around the number 1. And so we continue, and we can look at this problem here, and we can look at 10 to the n. So 10 to the power of n, where n, again, is any integer. So if we think of n, when n is positive, what we can do is we can say in general that we can move the decimal place some n amount of times, whatever that is, to the right. So when n is positive, we're moving the decimal place to the right. So what does that look like? Well, let's look at an example here of what that would really look like. So if I gave you 10 to the power of 4, okay, well, what does that look like? Okay, well, what we can move to is, if, like I said, we start with the number 1. Now, with the number 1, where is the decimal place? Well, the decimal place is right here after the 1. So we have our decimal place here. And if we move this decimal place n times, well, what is n? N in this case is 4. Is 4 positive? Well, yes. So I'm moving it to the right. So I can take this decimal place and say 1 space, 2, 3, 4 spaces. And so now I have my new decimal place. And then I can fill everything else with zeros. So 1, 2, 3, 4. So if it's positive, you can also think of adding that many zeros. So we could add 4 zeros. It works the same way. And so now what we have is 10 to the 4th power. If you put that into your calculator, if you have a calculator handy, if not, go ahead and pause and get your calculator. You'll see that 10 to the power of 4 is indeed 10,000. And so we can do that with any kind of combination of any positive number. So we can either move the decimal place that many times, so in this case it was 4 times, or we can think of this also, if n is positive, that exponent is positive, we can add that many zeros, because how many zeros did we add? We added 1, 2, 3, 4. What was our exponent? 4. And in a similar fashion, we can say when n is negative, when that exponent is negative, so 10 to the n, when that n is negative, move the decimal place n times, but in this case we're moving it to the left. So negative to the left and positive is to the right. So what does this one look like? So if I gave you the example 10 to the power of negative 6. Again, like we said, everything revolves around 1. So we start with the number 1. Okay, where's the decimal place? Well, it's right here. Now we want to move this 6 places. So we're going to kind of go backwards here, because to the left is this way. So we can say left 1, 2, 3, 4, 5, 6 places to the left. I'm going to put my new decimal place right here. And then so I have 1, 2, 3, 4, 5. So my answer here then, so 10 to the power of negative 6 is equal to 0.000001. Now this is a little bit different than the positive example, because now how many zeros do I have? Well, I only have 5 zeros, But if I look at this, this is 1 decimal place, 2, 3, 4, 5, 6 places away. And so that's exactly what I wanted. So when we look at the negatives, what we can do is we can kind of use the same rule and say, well, how many zeros do I add to the left? Well, you do 1 less than the number. So if this is -6, I can add 5 zeros to the left. Where in the other example, I would add that specific number of zeros, but when we're talking about negative, things get a little bit different. So for the time being, you can just think of this as moving it 6 times to the left. So when it's positive, we're moving to the right, and when it's negative, we're moving to the left. So whenever you see a negative exponent, you'll always get a decimal. And when it's positive, you'll always get a pretty big number. And so now we're going to look at some examples. And we can actually convert from exponents to what we call more of a decimal notation. And so the first column here, this first column has everything to do with our exponents. So what we want to do is we want to convert from an exponent to an actual number. So what is this number? So again, we start with the number 1. And since it's negative, we're moving to the left. And how many places are we moving to the left? 2 places, because the number is 2. So we're going to the left 2 places. So my decimal place starts here. And so I go 1, 2. Fill everything else with a 0. And then put my new decimal place. So 10 to the -2 power is just 0, 0, 1. And that's it. And I can do the same thing here. So how many am I moving to the left? So my example B. So I'm moving to the left or to the right? Well, I'm moving to the right because it's positive. And how many places? Well, I'm moving 5 places. Now, since it's positive, I can say that I can add 5 zeros. So I can say the number 1 followed by 5 zeros. 1, 2, 3, 4, 5. You can conveniently add your commas if you'd like to, so that we know that 10 to the 5th is equal to 100,000. In our last example here, example C, we're moving this to the right because it's positive, and we're moving this 10 places, or we can add 10 zeros. And so we can say 1 with 10 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we can add our commas here, here, and here. So if you know your place values, this is hundreds, thousands, millions, this is 10 billion. And if we look at our other example, what I want you to do is I want you to move this to an exponent form. Now again, we want to think of the number 1. So how can I make this number look like the number 1? So if I put a decimal place right there, does that piece right there look like the number 1? Well, yeah. And so what I can do is I can count up the number of places, because if we think about this, our decimal place is always here. We always have the imaginary number at the very end, if we don't have one. And so what I can do is I can count up the number of places and say, well, it took me 1, 2, 3, 4, 5, 6 decimal places to get there. And so I can say that if I use the number 10, this is 10 to the power of 6, because it would have taken me 6 places to get to that number. So if we look at some of the examples over here and how those kind of work and match together. Let's look at the second example B. Same thing, how do I get this to look like number 1? Well, what I want is I want my decimal place to be right there to the right of 1. And so how many decimal places does it take me to get there? 1, 2, 3, 4. And so what I can say this is 10 to the power, well, it took me 4 places, right? Well, I have to think also too, remember I told you negative exponents will always give you decimals. And so this is going to be a -4. And if you wanted to check these to make sure that they were right, all you have to do is try this again and work it from the opposite side. So I can take that 10 to the negative 4 and say, well, I can have my 1 move my decimal place 4 times to the left. And so I can make sure that it's right. And my last example is I have 1,000. And so I can say 10 to the what power? Well, I can also say, well, how many zeros are there? There's 1, 2, 3 zeros. So I can say that this is 10 to the power of 3. Because I know that this isn't going to be negative 3. And why do I know that this isn't going to be negative 3? Because this is not a decimal. And since it's not a decimal, like example B up here, I know that my exponent is always going to be positive. Okay, so we've come to the point where you can go ahead and practice. So if you want to switch over to your book app, if you're using your iPad to watch this video, do guided practice 3, 5, and 7. Now, those are the ones that you can check the answers on, so go ahead if you need to do that, and then come back and we'll finish the notes. Okay, so now we would need to move on expanding this idea of changing the decimal place when we have our exponent, when we have that 10 to whatever value that is. And so what if I asked you to find these following values? I wanted you to take 125 and then multiply it by power of 10 to the 5th. Now that seems a little confusing at first, but if we think about this, now we can always multiply something by 1, right? So everything that we've been doing kind of looks like this. It's always 1 times 10 to the 5th, and that's, like I said, everything kind of revolves around 1. So what if I take that 1 and multiply it by 125? Well, not a whole lot changes, and so what I can do is instead of starting with the number 1, this is in a way telling me that I want to start with the number 125. And I have already my decimal place that's kind of created already, so 125, and multiply it by this. So this piece here, the 10 to the 5th, this is telling me to do what? This is telling me to move the decimal place 5 times. It's telling me to move it 5 times to the right. And so I can do just that. And so I can say 1, 2, 3, 4, 5 places, add my new decimal place, and then fill everything else in with zeros. So all those places I skipped, I add a 0. Now, if you look at these little loops that I'm making, I'm leaving just enough space to add a 0 in there. And so now what I can say is that 125 times 10 to the 5th power is actually the following number. It's actually 12,500,000. Okay? Because what I really did is instead of using 1 to start with, this is telling me that I want to start with 125. And then I can do the same exact thing. So this is telling me 125, and then move your decimal place 5 times to the right. The bottom example here is the same thing, but now we're going to look at the negative exponent. This is telling me I want to start with the number 36.2. So start with the number 36. So start with the number 36.2. And I want to move the decimal place. And by now you should tell me this is 3 places to the left because it's negative. And so what I can do is I can take this decimal place that's right here, it's already there for me, and I can move it 3 places. So 1 place, 2 places, 3 places, put my new decimal place, and put it in blue now. And then I can add everything else that I skipped with a 0. So now my new number, so 36.2 times 10 to the negative 3 power, is actually 0.0362. And if you put that in your calculator, just like that, you'll find that you get this exact answer. So instead of rushing right away to your calculator, what we can do is we can use these cues that when we have something to the power of 10, we're just moving the decimal place. And it tells us either to the left or to the right. Now another way to think of this, as I mentioned the number line once before, 0, this is -1, and +1. And we start with 0. Positive numbers are all to the right, and negative numbers are all to the left. So if you ever get confused on which one is which, think of a number line. So the first example, 10 to the 5th power, that's telling me I needed to move it to the right because 5 is positive. And in the second example, -3, well, -3 is a negative number, obviously, and so we can move that just to the left that many times. Okay, so we're going to look at some examples here now. And so if I have 853.4 times 10 to the 5th power, again, I'm using these cues, saying this is telling me how to move my decimal place. This is 5 times to the right because it's positive. So what I do is I just simply write my number, 853.4, and then I can move that decimal place 5 times. So I'll take that decimal place that's right here and move it 1 place, 2 places, 3, 4, 5, and then put my new decimal place, and then fill everything else with a 0. 1, 2, 3, 4. Now, in this case, if you can see, this isn't necessarily telling me how many zeros to add anymore, because my decimal place isn't necessarily in that same area. So when we're talking about just the number 10 to the 5th, yeah, that's a different case. But when we're adding a different number, you can't always just add that many zeros. And so if I continue with this, my new number is 8534 followed by 4 more zeros, and then I can add my little commas in there. So now my new number here is 85,340,000. And you can check that in your calculator. Just take 853.4 and then multiply it by 10 to the power of 5. Or you can do 10 to the power of 5 first and then do it the other way. Because remember, multiplication, we can do that in any order. Now our last example, we're going to use the negatives. So if we use the cue of 10 to the power of -2, this is telling me to move the decimal place 2 times, but this time we're moving to the left. Now, if you want to save some space, you can just do it like this. But what's going to happen is you're going to run into some stuff, but I'll show you. So I can take this decimal place once, twice, and add in my 0 and then my new decimal place. But I don't like to do that. So what you can do is we can just rewrite our number, 0.163. Here's my decimal place. I want to move it 2 times to the left. So we go 1 place, 2 places, add my new decimal place, fill in my zeros, and so now I get a new answer of 00163. And that's what this value is. It's just a different way of writing it. Okay, so now we have another practice session. So you can go ahead and pause the video if you're on your iPad and switch over to your book app. And you're going to do guided practice 9 and 11. And once you're finished with those, you can check those because, again, those are odd problems. And you can just click blue button. Now, on these ones, they're not going to really show you any work, but you have to remember of when and how you're moving your decimal place. Okay, now what this brings us to is something that we call scientific notation, and you'll see this a lot as you continue, not just in math, but as in science. And scientific notation is simply a method of writing numbers that are either very large or very small. Because think about it, if you were to try to write the number, let's say 1 million to somebody, you would have to keep writing those zeros and writing and writing and writing, and you kept explaining 1 million a bunch of times. Or a really small decimal. If you were to show a really small decimal, let's say something like this, So 0.0000000000000000000001 to somebody, would they really know what that means? Probably not. And so it's not very easy and very convenient to write those. And so what we can do is we can write these in what we call scientific notation. And scientific notation has two parts that are being multiplied together. The first part is a number that is greater than or equal to 1 and less than 10. So if you look at these numbers in red, this number here and this number here, these are between 1 and 10. So we don't want to have anything less than 1, and we don't want anything over 10. And then the second part is our power of 10. And this can be any number. But what this is showing us is this is showing how many decimal places are involved with that number. So in that example that I gave you, I could rewrite that. Let's give you a smaller example. So instead of writing, well, let's just look at this example, 3.5 times 10 to the 11th. So if I use that, and I could say 3.5 this would be that number. And most of us probably don't know what that number is. So this is 350 trillion. But would you want to say 350 trillion a bunch of times and then write all those zeros all the time? Well, no. So what we can do is we can simply write this number in what we call scientific notation, which is 3.5 times 10 to the 11th power. And then just a side note here, standard form, which is just not anything to do with slope, but the standard form, or what we call decimal notation, is this right here. So writing out 350 trillion is what they consider standard form or decimal notation. So scientific notation is just, in a way, an easier way to write numbers, especially that are very large or very small. Okay, so now what I want to do is I want to write these in scientific notation. And so what I can do is I can kind of have a general rule of thumb. Now when we're converting to scientific notation, we kind of do things a little bit backwards. So if I'm deciding whether my exponent needs to be positive or my exponent needs to be negative, it's kind of a general rule of thumb, and if we think of it, things are backwards. Now, when I told you that we were looking at whether it was positive or negative, we moved either to the left or to the right. So, if we move if you move left, your exponent is positive, and if you move to the right, your exponent is going to be negative. So either making something bigger or making something smaller. And so basically what you can do is you can say that we're going to do plus 1 for every place that we move, and then minus 1 for every place that we move to the right. Okay, so we can look at this and we can say, okay, well what we want to do is we want to make a number that's between 1 and 10. So if we look at all these numbers, all our decimal places are at the very end, unless, like on the very last example, that it shows us an actual decimal. So what we're going to do is we're going to move this one 1, 2, 3, 4, 5, because 1.43 is a number that's between 1 and 10. So I have 1.43, that's part 1 of a scientific notation. Part 2 is times 10 to some exponent. Now, which direction did we move? Did we move to the left or to the right? Well, we moved to the left, and that means my exponent is going to be positive, or I can say I get plus 1 for every time I move my decimal. So I moved it 5 times, and so I get plus 5, which is to the 5th power. Okay, let's look at the next one. So again, we have our decimal place here. We want to move it till we get a number between 1 and 10. 1, 2, 3, 4, 5. So we have our new number, which is 2.35 times 10. How many times did we move it? We moved it 5 times. Well, is that a positive 5 or a negative 5? Well, we moved it to the left. Remember, if we move it to the left when we're converting, then it becomes positive, or plus 1 for every time we move it. Another way to look at this is, remember I told you, your exponent will be positive if you have a really big number. Or if you have a really small number, then your exponent is negative. Now, small number meaning something that looks like this. Okay, this is a very small number in comparison to what, 0 or 1 would be. This is a lot smaller than 1. And our last example is a little bit different kind of example. And so what we're doing is we're looking at something that's kind of already in a scientific notation. Or is it? Well, if we look at this number, is this number truly in scientific notation? Well, it's got a number here, and it's got the base 10 exponent. Well, that's not what we really want, because remember, we want a number that's between 1 and 10, right? Is 36.2 between 1 and 10? Well, no. So what we need to do is we can use the same kind of thing, and we can say, well, we need to move our decimal place once, so we get 3.62 times 10 to the, well, we started off with negative 3. Now this is where that plus 1 minus 1 thing kind of comes in handy. So if we look at this and we think about, well, it's going to be negative, or we can say, what direction did we move? Well, we moved to the left, and so what we're doing is we're actually getting a plus 1 bonus. And so if I take negative 3 plus 1, I get negative 2. So instead of being to the negative 3, I get to the negative 2 power. And if you don't believe me, what you can do is you can work this out, write it as an actual number, and then go all the way back. So we could write it like this, 36.2, move it 3 times, 1, 2, 3, decimal place. So I get a new number of 0.0362. I can convert back to a scientific notation. Moved it once, twice. 3.62 times 10. I moved to the right this time, so I get negative 1, so negative 2. Well, look at that. Those two are exactly the same number. Finally, what we have is sometimes what we want to do is we want to compare numbers in scientific notation. And every single time that we've compared numbers, what did we have to do? We had to make numbers look the same. So we wanted them to look the same. Well, do these numbers look the same? Well, no. And how do we know if these numbers look the same? Well, if they look the same, what we're going to look for is we're going to have the same exponent. So what we can do is we can do kind of what we did on that very last example and get these to have the same exponent. Now, remember what we said. If we move to the left, we get a bonus of plus 1, and if we move to the right, we get negative 1. So we get that bonus of to the left plus 1, to the right minus 1 each time we move the decimal. And so let's convert one of these. It doesn't make a difference what one we want to do. Well, I need to know, how do I get negative 1 to be negative 2, or negative 2 to become negative 1? Well, what do I need to do here? I need to plus 1 here. So I could do to the left. Or on this case, if I wanted to do the other one, I could go minus 1, because negative 1 minus 1 gives us negative 2. So again, it doesn't make a difference which one we choose. We just need to make sure that we either get these to be exactly the same. So if I choose this one, I want to change this one. What I want to do now is I want to say, well, how do I get negative 1 to become negative 2? Well, I have to subtract 1. And so I have to move my decimal place to the right. So move right. one place. And so what I can do now is I can take 8.5, move it to the right, so this is this direction, put my decimal place. So now my number is 85 times 10 to the negative 2. Pretty cool. And so now I have 58.5 times 10 to the negative 2. Well, now this is where it gets a little bit trickier. Which one is the bigger number? Which one is the bigger number? Now keep in mind, these are both decimals with zeros and some number at the very end. So we don't have to worry about negatives, we just have to worry about which one is going to be the bigger number. And so what we can say is that 85 is obviously bigger than 58. So we can say this. And so if I asked you to list these numbers from biggest to greatest, if I gave you a whole bunch of them, the easiest way to do this is to make the exponent all the same. And remember this rule over here. If you move to the left, you add 1. And if you move to the right, you subtract 1. And that's going to be it for today. So once you get done with this, okay, make sure that you do some of the other guided practice. If you want to work on it on your own, you can do the even numbers of the guided practice, and then tomorrow or on Monday in class you'll be doing what you did before.